Here for number 5, want us to understand our proofs. Like this is what we call the two-column proofs. Right? We call it two columns because there's a column where I'm going to have some statements. Let me use red here. I'm going to column where I have some statements, and I'm going to have a column where I'm going to have some reasons. I start with something. So I'm going to start with a statement. A, B, C, D is a parallelogram with the diagonal BD. And I have to have a reason why I start there, like why. And then I have a place where I'm going to finish. Here, my instruction says, given a parallelogram, and then we see the parallelogram at the bottom, prove theorem of opposite angles. Opposite angles is something about angle A and angle C. And as a matter of fact, I'm going to say angle A is equal to angle C. So, matter of fact, that's what I'm going to say. That's what I want to show. But the thing is, I'm not going to just say it. I'm going to prove it. So that's what we call this a proof. First of all, ABCD is a parallelogram. Well, that's basically what we were told, right? Given a parallelogram with diagonal. Diagonal is a segment that crosses inside the figure, right? It connects two vertices. Remember, my vertices are my points here. A, B, C, D. Those are what we call vertices. A diagonal, it's a segment that connects two vertices, but the segment goes inside the picture. Okay. Now here it says ABCD is a parallelogram with diagonal BD. Yeah, that's the diagonal that I see here. I was told that that's a diagonal. I mean, that's a parallelogram, and I see that's a diagonal. So I'm gonna say, why do I accept that? Well, that was given. Usually we start with something given. And then I want to say that angle 1 is congruent to angle 4. Interesting. I'm saying that angle 1 and angle 4 are the same thing. And angle 2 is congruent to angle 3. So I look at angle 2 here and I see angle 3 here, and I'm going to say, why is angle 1 equal to angle 4 and angle 2 is equal to angle 3? I remembered back in the days, we used to see, remember, parallel lines with a transversal. Remember that? And remember, I used to say that alternate interior angles were congruent to each other. So this angle was equal to this angle, and the same thing was this angle was equal to this angle. Remember, we used to call that alternate interior angles? Well, that's basically what I have here. Look, I have a parallel line to another, and I have a transversal. So isn't angle 3 alternate interior with angle 2? And angle 1 will be with angle 4. That one we will have to use another angle here. For that one, we will have for angle 1 and angle 4, because here I can see angle 2 is equal to angle 3 because of alternate interior angles, but not angle 1 with 4. Okay. But what if I chose these two to be my parallel lines and this other one to be my transversal? Then I will say angle 1 is equal to angle 4 for alternate interior angle. So my reason why I'm going to accept this, I'm going to say alternate interior angle theorem. Theorem is basically a fancy way of saying rule. Alternate interior angles. Okay. So I just said those angles are equal. Angle 1 is equal to angle 4. Angle 2 is equal to angle 3. Okay. Then BD is congruent to BD. Well, isn't BD this segment? I remembered. I remember I used to tell you guys before, if two triangles use the same segment, you can mark it. And I kept on telling you guys you could. Remember when we used to prove for congruent triangles like side, angle, side. Remember those? And I used to say if one side is used by both triangles, you can just mark the side. I just told you you can do it. I just never told you why. And the reason why we do that, there's actually a rule. I haven't mentioned it before, but I will today. The reason why we call this reflexive theorem or property. Reflexive property basically says one segment is equal to itself, but here we're going to use it because one triangle is using it, another triangle is using it. When two triangles use the same side, we can mark it and based on reflexive property. Now here, why is triangle ABD congruent to triangle CDB? Let's paint this two triangles. I'm gonna go one of them yellow, triangle ABD. And there's another triangle CDB. Now, for us to prove that two triangles are congruent, we use the rules that we learned recently. And those are like side angle side. Remember HL, remember all those rules that we learned. Now, what do each triangles have? Remember, I came in and I said, when you're looking at the triangles, you got to ask yourself, there's two of something, like either two sides or two angles marked on each triangle. So when I'm looking at the yellow triangle, I see two angles. Remember, I'm asking two sides or two angles. And again, I'm looking at the things that are marked. I see two angles are marked. So I'm just going to write angle, angle. And then there's a side as well. And I ask myself, is the side in between the angles? If it is, put the S in between the A's. If it is not, don't put it in the middle. In this case, is the side between the angles? Yes, it is. So I'm going to put the S in between. Is angle side angle a rule? Yeah, it is. I look at the green triangle, I see the same markings. So I'm going to say triangle ABD is congruent to triangle CDB because of angle side angle. Now, when you accept two triangles are congruent, honestly, you accepted a lot of things. When you say two triangles are equal, you accepted a lot of things. For example, let me use the first letter of each triangle, the first two letters of each triangle. You accepted the segment AB is congruent to the segment CD. We accept it as soon as we say they are congruent. Using the last two letters, BD and DB, I'm going to say the segment BD is congruent to the segment DB. Not only on that, but if I use the first and third letter, so let me ignore the middle letter, the segment AD is congruent to the segment CB. As soon as you say two triangles are congruent, remember it means same shape, same size, you accept that one side of one triangle is equal to another side of the other triangle. You immediately accept that. Not only that, but also the angles. You're going to accept that the angle ABD is congruent to the angle CDB. And you're also going to accept that the angle BDA is equal to the angle DBC. And lastly, the angle DAB, it's congruent to angle BEC. CD. Notice how the order of the letters. I was just going the first three letters is equal to the first two letters. And then for my second triangle, I started from the middle. So BDA is equal to DBC. You see my pattern here? And lastly, I said angle DAB is equal to angle BCD. But remember how there's one way we can write angles in a shorter way. So what I mean with that is, let's take a look at angle DAB is congruent to angle BCD. Can I just write that as angle A is congruent to angle C? And that's basically what I have here. Nice. So yes, I can. Now remember, once you accept that two triangles are equal, you accepted that three sides of one triangle are congruent to the three sides of the other triangle. And the three angles of one triangle are equal to the three angles of the other triangle. You accepted a lot of things. And the rule we're going to say that. Let me just abbreviate this, okay? I'm going to go C, P, C, T, C. You guys might be like, what in the world is that? The abbreviation for this is congruent parts of congruent triangles are congruent. Let me read that again. Remember, I just abbreviated using the initials. Congruent parts of congruent triangles are congruent. I've seen in your guys' messages, when you guys do message, I've seen the abbreviation IDK. And isn't that just abbreviation of you guys just writing the first letter of each word? So if you guys do it on the text, math has been doing it for decades or centuries in this case. CPCTC means congruent parts of congruent triangles are congruent. As soon as you accept two triangles are congruent, you accept six different statements, right? There's corresponding sides, there's three of them, and there's corresponding angles. Okay, that's how you're going to be doing uh, your angles here, your proofs. But not only how do we complete the proof, there's a couple things I want us to see. Okay, there's a couple things in a parallelogram, because these are things we're going to use in the future. In a parallelogram, I have a diagonal. My angles on the side are going to be equal. Like one angle is just that they flip. See how here on our picture, angle 2 is equal to angle 3 and angle 1 is equal to angle 4, but they got flipped? That's something we're going to be using for later. And then remember how we used to say that the three angles of a triangle add up to 180? Remember we used to do something like that? So let's say in my yellow triangle here, let me call this angle A, let me call this my angle B, and let me call this angle C. Can I just admit this is angle C as well? Because remember how they're the same, angle 2 and angle 3 are the same? And if I add the three angles, A plus B plus C, it's equal to 180. One thing I want us to see here, very, very interesting part here. Very, very interesting. This is actually, want to make sure we see this. If I have a parallelogram, and I see the two parallel lines here, and then here's one of the sides. I'm going to do black. If I add adjacent angles are basically the angles on the same side, right? Angles that are equal to each other. If I add adjacent angles, that will be A plus, now this one is B plus C, but we had it accepted earlier that A plus B plus C were the three angles of my triangle, so it's equal to 180. So adjacent angles, like it's something we're going to be using soon. Adjacent angles on a parallelogram, you add them up and equals to 180. Having that said, let's take a look at question number 6. It says solve for x. Each figure is a parallelogram. But didn't I just say that adjacent angles, if you add two adjacent angles, two angles that are next to each other, you add them all up and it's equal to 180. So that's exactly what I'm going to do here. I'm going to say 5x plus 14 plus 31 plus 85. I just want us to see that it's this angle. I'm adding everything. That angle was broken into two parts, so I'm adding it. And then this 85 comes from here. I'm adding everything, and this is equal to 180 because adjacent angles on a parallelogram add up to 180. Okay, let me separate my sides to the equal sign. Let me make these things a little bit more simple. Letter-wise, 5x. That's the only term that has an x. Number-wise, 14 plus 31 plus 85. I'm going to grab a calculator if necessary. I'm going to add these things up. 14 plus 31 plus 85. You don't see my calculator, but I am using one, and it says 130. I'm going to simplify that as 130. So I have that 5x plus 130 is equal to 180. I want the 5x by itself, so this plus 130. Let me move it over as a minus 130. So I have that 5x is equal to 50 because 180 minus 130 is 50. To get the x by itself, let's divide by the number in front of x because 5 divided by 5 is 1. So 1x is equal to 50 divided by 5 is 10. Okay, let's take a look at another example. Let's take a look at number 7. Here it doesn't say solve for x, but I see some x's in there. Here, let me solve for x, and then I'm going to use it according to what I'm being asked here. So do notice that question 6 and 7, they kind of look alike, but they're not necessarily the same thing. If I add this angle with this angle, because remember they're adjacent angles on a parallelogram. If you see it, there's my two parallel sides, and there's one of my sides here. Add those two angles. So I'm basically add everything. 10x plus 12 plus 5x plus 2 plus 46. I'm adding everything and it's going to equal to 180. Like I said, it doesn't say for me to solve for x, but I'm going to solve for x to be able to answer the question. So letter-wise, 10 plus 5, that gives me 15x. 12 plus 2 plus 46. Well, that's 60. So I have that 15x plus 60 is equal to 180. Okay, I want that x term by itself, so this plus 60, let me move it over as a minus 60. So I have that 15x is equal to 120. Let me divide both sides by 15. I know 120 divided by 15 is 8. Use a calculator if you need to. X is equal to 8. However, they were not asking me to solve for x. They were asking me to find the measurement of angle S. Well, angle S is right here. What I know about angle S is 10 times x plus 12. And I know the value of x, right? I'm just going to write 10 times 8 plus 12. So instead of x, I wrote 8. And I'm using 8 because I know x is equal to 8. So I need you to solve for x and then be able to use it. Okay, I know 10 times 8 is 80. So I have 80 plus 12, which is equal to 92. So be careful. Some questions like number 6 are just going to ask you solve for x. Solve for X and you're done. Questions like number 7, you're going to need to solve for X and then use that measurement to find the value that they're asking you here. They're asking me for the measurement of angle S, so solve for X to be able to solve for that.